Inheritance is a topic that is so essential not just in Unreal Engine, but in object-oriented programming in general. Just about any system that you can think of, whether it be guns, collectibles, NPCs, buttons, levers, switches, doors, etc., will leverage inheritance to some extent. There's really no getting around using inheritance, so I want to say right off the bat that if my video doesn't help you, please watch every video on the internet about inheritance and practice using it until you have a good understanding of it, because it will make your life a lot easier. So first we're going to start out by talking about what inheritance is and the concept behind it, and then we're going to make a basic pickup system that leverages it. So in a nutshell, inheritance involves consolidating code into a base class. When you make a given system, let's say a collectible system, all of your collectibles are going to share some common functionality. Anything that they all have in common would go in the base class. Then you derive that functionality from the base class by creating children classes. And if that sounds confusing, don't worry, we're going to have a look at this right now. And you may not have known it, but you've been using inheritance anytime you've ever created an actor or any other class in the engine. So when you go into your content browser and you right click and create a new blueprint class, I want you to notice that at the top of this window it says pick parent class. So anytime you select one of these, what you're actually doing is you're creating a child of one of these classes. So if I select actor, for example, I've now created a child of the actor class, and I can just call this my actor. And if I open this up and I click this cogwheel here, make sure you have show inherited variables selected, and you can see there's a whole bunch of stuff here by default. And this is all stuff that's declared in the base actor class, which is written in C++. And it's a lot of different things that are useful in general for any class that you're going to create and put into your world. It's a lot of networking stuff. You have tags here in the variables. Also, there are a bunch of different functions that come built in. So if you look at this function section here, there's this override drop down, and we'll talk about what overriding means. But you can see there's all these different functions that are useful in general to any class that you're going to create. Another thing you may not have noticed is if you go to the class settings, over here on the right under class options, it says parent class, and it shows you that the parent of this class that we created is actor. So why is any of this useful? Well, once upon a time when I was in school, we were given the task of basically competing in a game jam where we had a month to make a game based around a topic. Now, I didn't really have a good understanding of inheritance, and my game involved a lot of different doors. So what I wound up doing, which this is a terrible thing to do, is I went in and I created a door blueprint, and I gave it all the functionality needed for a door to work and all the components and whatnot. And then when I needed other doors with different static meshes or different properties, I just duplicated that door blueprint and then went in, got rid of any code I didn't need, added code that I did need, and then again would duplicate it and duplicate it and duplicate it. And this is so bad for so many reasons. The biggest thing being, say you realize, I want all my doors to open away from the player, but I didn't do that when I first started making that first door class. Well, now you have a whole bunch of separate classes that you have to go through and copy and paste code over and over and over again in order to add that functionality into all your doors. Whereas, if I had created a base door class and derived all my other doors from it, I would have only had to edit that base door class and everything would have applied to all the children classes. So in general, if you find yourself duplicating blueprints over and over again, or copying and pasting huge swaths of code from blueprint to blueprint, that's probably a time where you should be using inheritance. So now let's take a look at how we are going to structure our collectible system. So whenever you're using inheritance and you're making a system, it's going to depend on your game's design. So in my case, what I'm going to be making is a collectible system where you simply walk up to the collectible, and when you collide with it, you pick it up. We're going to make some shields, we're going to make some health pickups, and we're going to make some coins. So the structure of its hierarchy is going to look something like this. We're first going to start with an actor, because we're not making a pawn or a player controller or anything else like that. We just need a generic class such as actor to start from. And we're going to create a base collectible class. Now that base collectible class is going to contain any variables, functions, logic, etc. that every collectible in the game should have. We'll take a look more specifically at what these properties are as we build the system, but anything that all the collectibles in the game should have is going to go in this parent class. Now, as I said, for our system, we're going to make shields, health pickups, and coins. So what we're going to then do is from that base collectible class, we're going to create 3 child classes. We're going to create a base shield class, a base health class, and a base coin class. And then finally, from each of those classes, we'll actually create the assets that are going to be used in our game. So we'll have a bronze shield, which restores 1 shield, a silver shield, which restores 2 shields, and then a gold shield, which will restore all of our shields. And then the same sort of concept for the health. We'll have a simple heart and then a max health pickup. And then with our coins, again, bronze, silver, gold. Bronze is worth the least, whereas gold is worth the most. Now, why are we going to structure it this way? Well, let's say later on we decide, we should have added some property to our collectible system that applies to all of our collectibles. Well, then we can just go and we can edit that base collectible class. But let's say also we wanted to add something to just our shields. Well, instead of adding it to our base collectible class and affecting all of our pickups, we can just edit our base shield class. So enough talking and enough theory, let's just get in and let's build this system. This is the system we're going to be building. You can see we have a bronze shield, silver shield, gold shield, and the different hearts and coins. And when I walk up to one of these, in the top left corner, you'll see we're just printing out how many shields we have. So right now I have 1 shield, and if I pick up this silver shield, I'll have 3 shields, and I have it clamped so that you can't get more than 3 shields. So if I try to get this gold shield, it's not going to work. Whereas if I start over, I have 0 shields, I get the gold shield, and it maxes it out. And it's the same sort of concept with the hearts. I can pick up this max heart, and I get 100 health. I can pick up a gold coin, and I get 100 coins. Silver coin will give me 50. And so on and so forth. Real quick, I want to point out that all of these meshes are just simple static meshes that I made in Blender, and I will put a link in the description to download them if you would like to follow along. Let's get started. Alright, so really super fast, some quick setup for our project. I'm here in a blank level, and I've created a folder called Inheritance Tutorial, and inside of it I've put a collectibles folder. You'll see I have this asset folder. In the meshes, we have those meshes, and I've included a couple of extra in case you want to try and make your own collectibles. And what I want to look at real quick is this material that I created. It's super simple. We just have a vector parameter here for base color so that we can change the color of our collectibles, and I just have a constant scalar value here going into the roughness of 0.5 so that it's a little bit shiny. From this, we're going to create a material instance, and again, that's going to let us change the color on the fly inside of our blueprints. So now what we're going to do is I'm going to create a new folder, and I'm going to call it bases. And right away, what I'm going to do is create that base class that we talked about. So new blueprint class, actor, and we're going to call this BP base collectible. So like I said, in here, we're going to give this any functions, logic, variables, and other properties that all of our collectibles should have. So the first thing I can think of is all of our collectibles should have a static mesh. So we'll add in a static mesh, and I'm just going to set a placeholder mesh for the time being so that we can see what's going on, and we can change this in our children as we'll see. Now, one property of the static mesh that I want to be the same across all of my collectibles is I don't want it to have any collision. So I'm going to go over here to the collision settings, and I'm going to set the collision to no collision. Great. Now the next thing we're going to do is we're going to add a sphere collision, and this is how we'll detect when the player walks into our object. And I'll just name this collision sphere. And real quick, we'll just size it up so it's nice and big. So before we get started actually making the collectibles, I just want to show you real quick what we have in the first person player character. And this is obviously just for the sake of demonstration. In a real setting, you would have some sort of inventory system, but we're obviously not going to do that for this video. So I have a current health variable, which is a float, a current shield variable, which is an integer, and then a total currency variable, which is another float. And I'm just printing these values out off of tick, and for the duration, I have world delta seconds plugged in so that it prints every tick for 1 frame, making it so that it just shows up in the top left-hand corner consistently like so. Alright, so the next thing I want to do is I want to get that material set up real quick. So we're going to go into the construction script, and we're just going to create dynamic material instance on the static mesh. Alright, the source material is going to be that collectible inst that I created earlier. And then from here, we are going to promote it to a variable, just because that may be useful down the line, and we'll call this material. And then off of here, we're just going to set vector parameter value, and I named it color. And we will promote this color value here to a variable, and we'll call it color. And we will make sure to expose it. Now, another thing to keep in mind with inheritance is if you set the scope of your variables to private, they will not show up in your child class. So this material instance here, I don't want to edit it directly in my children classes, so I'm going to set it to private. And it's good practice to make private any variables that shouldn't be touched in children classes. And this is mainly so that other people working on the project don't mess with anything that shouldn't be messed with. Great, so now when we make children classes, we'll have the ability to change their color on the fly because we'll have access to this color variable. So now let's start thinking about other things that we need to implement into all of our collectibles. Well, when we collide with this collision sphere, we want to do some stuff, assuming that it's the player colliding with it. So we'll select our collision sphere in the components panel, and we will look for on component begin overlap. Now, what I'm going to do here may be a little confusing, but for the sake of simplicity, I'm going to cast to BP first person character, and I'm simply doing this as a check to make sure that it's the character overlapping and not some other object in the world, like maybe the projectile or whatever. I'm not getting any data off of here. Again, this is just serving as a check for the time being. Now, there's a little bit of prerequisite knowledge before I can explain this better, but we can't directly override component delegates in children classes, and that's what this is. This is a delegate that is bound to the overlap event in the collision sphere. So what we're going to have to do here is create a custom event. You could also use an event dispatcher if you wanted to, but I'm just going to use a custom event, and we're going to call this on player overlap. And you'll see why this is useful in a little bit. Now I'm going to give this an output, and it's going to be of type BP first person character, and we'll just call it character. And then if this cast succeeds, we're going to call that event. So on player overlap. And we have to compile and refresh this node so that that updates. And we'll just plug this in here. All right, good. So when our player walks into this event's going to run. And we now have this event to do whatever we want with, both in this base class and in our children classes. So now something that I want to think about is that in general, collectibles are probably going to need some way to determine whether or not they can be picked up. So as you saw in the example before, if you were maxed out on shields, you can't go over your max. But this is going to vary on a case-by-case basis depending on the collectible we're dealing with. However, we can still create a function and that basic functionality in this parent class, and then we will override it in the children. So if that sounds confusing, don't worry, just follow along, and as we progress through this video, it will make sense. So we're going to create a new function, and we're going to call it can be picked up. And we're going to add an input, and it's going to be the player character, so character. And it's going to be of type BP first person character. And we're also going to add an output, and it's simply going to be a Boolean called can be picked up. And for the time being, I'll check this as true. We're going to leave this as is with no functionality in here because you'll see on the children classes, that's where we'll add the functionality for this. So now back in our event graph, we can call this can be picked up function. We can pass in our player character. We can do a branch here. And now if it can be picked up, we want to do something. And that's going to heavily vary based on what the collectible is. So what I'll do is I'll create another custom event, and I will call it on pickup. And again, I'll pass a character reference. And then off of this branch, we can call that on pickup. Okay, so finally, let's think about things that we want to happen when we actually successfully pick something up for all of our collectibles. So again, the specifics of what happens. So for example, if we want to add shields or hearts or coins or whatever else is not going to happen here. It's going to happen on a case-by-case basis for our children classes, but there are some things that will happen for any collectible. So one thing I could think of that would be good to put here is playing sounds. So what I'll do is I'll get our static mesh and we'll do a play sound at location, and we'll just get the world location of this static mesh, plug this in here like so. And then what we can do is we can promote this sound to a variable, and we'll call it pickup sound. Now, let's convert this to a validated get, just in case we forget to set it. It's not really an essential functionality, so in case we forget to set it, we still want to be able to progress past this. So if it is valid, we'll play the sound. If it's not valid, we'll continue on anyways. And the last thing that I can think of that all of our pickup objects should do when we pick them up is destroy. So we'll just call destroy actor, and we'll plug our play sound here, and we'll plug this in as well in case there is no sound set. And that should do it for our top level base class. So to recap, what we're doing here is we're adding in our necessary components. When we collide with that sphere collision, we're checking if it's the first person character, and we're calling a custom event and passing that character in. That event will then pass in the character to this can be picked up function, which currently has nothing going on in it. And then a branch will run, and if the object can be picked up, we call yet another event, and we will try to play a sound, and whether or not that sound plays, we'll destroy the actor. And this is really the bulk of what we need to do for collectibles. And the good thing is we never have to rewrite any of this code ever again. If we weren't using inheritance, we would have to do this kind of stuff over and over and over again for all of our collectibles. So this class should be done now. So to create a child class, there's a few ways you can do it. The first way is to go to the Create Blueprint Class menu, like you normally do, and then in this All Classes section, you can type in the name of the class you want to create a child of. So in this case, we want base collectible. Another way is you can right-click on that base class, and you can see that it says Create Child Blueprint Class. So let's do that, and I'm going to call this BP Base Shield. Now let's open this up. And you're going to see we have all that stuff that we added in the base pickup class. And if we go to the event graph, we see some interesting nodes here. We see these add call to parent function nodes coming off of begin play, overlap, and tick. And basically that means that when event begin play runs, anything that happens on the parent is going to run when this node gets called. It will also happen if I simply remove all of this and don't have any of it in here. So you can see that none of that code we wrote in the first class is in here, but it will still run. So let's have a look at that. I'm going to change the static mesh real quick to the shield mesh. And as you can see right away, the logic that we wrote in our construction script is in fact running on the shield because the shield is now black. And if I were to go in here and change that color to something else, like white, you'll see it changes. Compile. Now if I add the shield into the scene, again, even though this graph is completely blank right now, it's going to run any of that parent functionality. So if I hit play and I walk up to the shield, you're going to see it destroys. But it really doesn't do much else because we haven't added any other logic into it. So now let's start getting into things that are specific to our shields. So remember we created that can be picked up function. Now we're going to want to take a look at that. So we're going to click on this overrides drop down here, and we're going to look for that can be picked up function. And notice how it shows you on the right hand side what class this comes from. So we have a whole bunch of overrideable functions in here, a lot of which come from actor, but notice that this can be picked up function comes from our base collectible. So we're going to click on that. And you're going to see again, we have that call to the parent function, and we'll leave that there, but we'll unplug this. And now we can start doing the logic to determine if we can pick up any shields. So first off, we need to add a variable here, and it's going to be an integer variable because our shields are stored as an integer variable, and we'll call this shields to add. Now, I apologize, I forgot to mention that in my first person character, I have some other variables here. I have a max health variable and a max shield variable, along with the other variables that I showed earlier, and those are going to be important right now. So we have this shields to add integer, and we're going to set those on a case-by-case basis. For now, we'll default it to 1. And we need to check if our character shields are maxed if we add this to it. So what we'll do is we'll get max shield, and we'll also get current shield. And what we'll do is we'll grab this shields to add variable, and we'll add it to our current shields. And if this is greater than our max shield value, then we don't want to be able to pick up our shield, so we'll leave this unchecked. However, if this is not the case, we'll set it to true, and what that means is this right here will pass, and we'll call this on pickup event. Real quick, I'm going to make this shields to add variable instance editable so that I can change it in the world. And I'm just going to set it to something way above the max, like 10, so that you can see if I walk into this, it doesn't destroy. So that's working. Now all we have to do is we go back to our event graph, and we will override our onPickup event and add in any custom functionality needed to actually add the shields to our player. So in our base shield, we're going to call that onPickup event. And like I said before, if you want the stuff in the parent class to run, once you call the event, you need to add that call to parent function. And to do so, you right-click the event and click add call to parent function. Now here's the thing, when this runs, it's going to play a sound and destroy the collectible, but we want our stuff to happen before the collectible gets destroyed, so we're going to call this after we do all of our stuff. And what we're going to do is we are going to get current shield, and we're simply going to add shields to add, and we will set current shield like so. And then we'll add that call to our parent function, and we'll plug our character in. Now if I hit play, I forgot to change that value. Let's set it to 1. If I walk into our shield, you'll see it adds 1 shield. If I set this to 3, which is our max shield, you'll see it adds 3 shields. And one last thing, let's make use of this pickup sound. So over here, I'm just going to set this to camera shutter. And now if I walk into this, you'll hear that sound play. So if you're starting to get a bit confused, that's okay. We've covered quite a bit. But bear with me because you're about to see the magic happen. So now that we have our base collectible and our base shield class, we're going to go and we're going to start creating the shields that will actually be used in our game. So what we can do is we can come out here. I'm going to go right into my collectibles folder, and I'm going to create a new blueprint class. It's going to be of type BP_base shield. And the first shield we're going to create is that bronze shield. So I'm not sure if this is a bug or what, but as of Unreal Engine 5.0, when I open this, I see the full blueprint, and that's not actually what is supposed to happen, or at least that's not what used to happen in older versions of Unreal. What I should be seeing right now is a data-only blueprint. Now, in order to get that to happen, I have to go in here and delete this call to the parent in the construction script, compile, save, X out of this, and now if I open this again, this is what you'll see. And the magic here is I can create shields and not write any new code. I can just edit those variables right here. It's data only. So if I want to change the sound for my bronze shield, let's change it to on button click. We'll change the color to something like, something close to bronze. And we'll keep it so that it only gives you 1 shield. But that's all I have to do to create this bronze shield. Now I can drag this into the world, and you will see when I walk up to it, it plays a different sound, and it only gives me 1 shield. And I can go and I can create another one, BP_base shield. And I'll call this silver shield. We'll go in. And even though this isn't showing up as a data-only blueprint, that's okay. Just make sure you have class default selected, and you'll see that same data right here on the right-hand side. We'll change this to 2. We'll put the sound back to that camera shutter that we had originally, and we'll make the color like a grayish, silverish. Just to really drive it home, I'll make it nice and dark like so. Compile. And now we have our silver shield. So if I go in and I hit play, I pick up this shield, it gives me 1. And I pick up this shield and it gives me 2. So now I have 3 shields. And just like that, we can create as many different shields as we want, and we don't have to write any new code. But more than that, if we did want to create a shield that did something different, we could just go in and add that functionality. So again, I'll go in, I'll create a BP base shield, and I'll call this gold shield. Again, change that data. Make it that color. I don't know, change the sound to this. We'll make it 3 shields so that it gives you max. And then just to demonstrate that I could make this do other things, I'll go in here and I'll call that on pickup event. And I'll just print string. And I don't know, I'll type, yay, max shields. This could be indicative of like having a particle effect play or something of that sort. You could go in and you could add anything specific that you want still. You're not limited to the functionality that you put in the parent classes. So we'll do that. And now I have to add it to the world, of course. When I go in and I pick the shield up, you'll see yay, max shields, and I have 3 shields. And now we are on our way to a great pickup system where all of the boilerplate code is already done. We don't have to copy and paste all of that common functionality across the shields. We literally just create a new shield, change the data. If there's any specific functionality we want to add, we can add it in. And by specific functionality, I mean new functionality. And that's really it. That's all you have to do here. We never have to write or copy any new code to create new shields. Now, this video is going to start getting long, so I don't want to spend too much time going through the hearts and the coins. It's really the same exact concept. The difference with the hearts is you're going to use a float variable instead of an integer variable. Same thing with the coins. You're going to use a float variable. And how you override the function for checking if you can pick up a heart is going to change. You're going to check against the player's max hearts rather than its max shields. And in the coins, you're not going to override that function at all. You're just going to leave it as is unless you had a max for coins. But in my case, the player can have as many coins as they can find in the game. So I'm going to speed through this, and real quick, I will go into my collectibles. I'll go into my bases. I'll create a new blueprint class. We'll make it a subclass of base collectible. We'll call it BP base health. And I'm going to speed this up as I go in and change these values. So one difference I'm going to add here in the condition for the hearts is we're not going to make it so you can't pick up a heart if it brings the player above the max. We're just going to clamp it. So what we'll do is we will check if player's current health is equal to their max health. Now, if the player's health is already maxed, then no, we don't want to pick up a heart. So we'll go like this. And if that's true, this will be false. Otherwise, we'll go true. And then in the event graph, on that on picked up event, we'll get the health to add. We'll get the player's current health. We'll get the player's max health. We will add the health to add to it. And we will clamp between 0 and max health. Plug this in. And then set the player's max health like so. And we're ready to start creating our hearts. So real quick, I'll create a new folder to store our shields in. And I'll create a new folder for health. New blueprint class, we'll make it a child of BP underscore health, or what did I call it? Heart base health. We'll select it and we'll call this BP, or we'll just call this basic heart. And we'll just change the data. We'll make it red. We'll give it a value of, let's say, 25 for a basic heart. I'll pick any random old sound. And this heart is good to go. So I can drag this in. And while I'm here, I will duplicate this heart. Now, I remember I said don't duplicate things, but at this point, it really doesn't make a difference because we're not adding or changing any code. These are both, duplicating this heart is the same thing as creating a brand new one. It's just going to start with the properties of this heart. So now I'm going to call this max heart, and we'll go in. We'll change the color to yellow. We'll make the value 100. And again, just any old sound. And I made a small mistake. We don't want to set max health here. We want to set current health. So I'll just delete that and set current health. Now we can plug that in, compile, and see, imagine if I had made all these hearts individual and I made that mistake on the first heart without testing. I'd have to go through all of them and make that change. But instead, I'll just change it here on the base heart. And now when I go in, you'll see that that added 25 to our health. And if I pick up the max heart, we will be at 100 health. And this tutorial is starting to get long. The coins are the exact same thing, except they're even easier because you don't have to override that can be picked up function. You just add in the logic to add coins, and I'm going to challenge you to create that one on your own. Also, in my meshes, I have a trophy mesh here, and I encourage you to think about how you would implement this as a collectible. Would you derive it directly from the base collectible class, or would you make a subclass for it? Let me know in the comments down below. Now, I've said it over and over again that doing it this way makes it so that if you have to make a broad change to everything, it's easy to do. So real quick, let's make a broad change to everything. I'm going to go to the base collectible class, and I'm going to make it so that when you pick up a collectible, we print out a string. And it's just going to say collectible picked up. I'll even change its color to like red. Give it a longer duration. Compile. And now if I walk into my shield, you're going to see collectible picked up. And let's say we wanted to do something to our shield, but not our hearts. So we can go into that base shield class. And we will go to this event picked up, and we'll add a print string that says, yay, we got some shields. And you'll see when we get a shield, we get collectible picked up, and yay, we got some shields. But if we pick up a heart, it doesn't print out that yay, we got some shields. And that is the magic of inheritance. Now, there is more to this topic than what I've covered in this video, namely when it comes to casting and data types, but I talk a good amount about that in my casting video, so I suggest you check that out if you want to know more about that. Also, a quick tip, if you're using interfaces and maybe you're using some sort of press F to interact system, one thing you could do is apply your interface to the base class, and that way you don't have to reapply it to every child class. I'm not going to do that in this video. I'm going to save it for when I make an interaction video, which is in the works as we speak. And when that's out, there will be a card popping up in the right-hand corner of the screen. But yeah, that's all there is to this video. Like I said in the beginning of the video, if you're still having a hard time understanding inheritance, practice, watch other videos, read articles, ask on Reddit, whatever you have to do to understand this concept better, because again, it's something that once you do understand it, you're going to be making use of it over and over and over again, and it will make your life a lot easier. Thank you so much for watching. I hope you enjoyed. If you did, please slap a like on this video. If you have any questions, comments, or concerns, leave them in the comments down below. For more videos from me, consider subscribing, and I will see you in the next one. Best of luck with your projects.